Finding logarithms is difficult, and for most numbers and most bases you're not going to be able to get an exact value, but under certain circumstances it's possible to do it. And let's take a think about these two questions. So log to the base 4 of 2. So what do we need? Let's just wrap our heads around this. We need a number, let's say a, such that 4 to the a is equal to 2. That's what we're looking for here. This is the meaning of the logarithm. What do I know? Well, 4 to the a, 2. 4 is bigger than 2, so it couldn't be 1, 2, 3, anything like that. It's going to have to be less than 1. What do I know? Well, I know the square root of 4 is equal to 2, isn't it, right? The positive square root of 4 is equal to 2. So 4 to the power of half is equal to 2. So observation. So the square root of 4 square root of 4 is equal to, well, it's 4 to the power of half, as I said. By definition, that's equal to 2. So this tells us that log to the base 4 of 2 is equal to, it's equal to a half. Now, B. What do we need? Well, same thing as before. We're looking for some number. I'll call it D again. So need a D such that 4 to the power D is equal to 32. And this seems quite a lot more difficult. We saw on the previous comprehension check that if it was 64 instead of 32, it was good because I had 4 to the 3, right? But it's a bit of a problem because if I do 4 to the power 2, it's equal to 16, which is less than 32. If I do 4 to the 3, it's 64, so it jumps over. So intuitively, I think my D has to be somewhere between 2 and 3, but what exactly is it? So what I'm going to do is something really clever. You can see several ways to do this, but this is a useful way to think about it. If I have the following, if I have 2, right? So I know the following is true. So 4, so this is a tricky example. 4 to the power of half is equal to 2. Now, what about 32 as a power of 2? What's that equal to? Well, 2 to the power of 4 is 16. 2 to the power of 5 is equal to 32. So why don't I take this expression and raise everything to the power of 5? Okay, so what's that equal to? That's equal to 32. But notice, because I've expressed 2 as a power of 4, it's 4 to the power of half, I can now use one of my laws of exponents. So this would now be 4, 5 over 2 is equal to 32. So I've done something really clever here. This is why it was a part A and a part B. So finally, what does this tell you? It tells you log to the base 4 of 32 is equal to 5 over 2. That's a difficult example. You've really got to kind of think carefully about the meaning of the logarithm and how you could possibly use it to get anywhere. And the real thing is, I mean, it's recognizing that 2 to the power 5 is equal to 32. When you spot that and you really follow through from part A, you end up being able to express 32 as a power of 4, which gives you log to the base 4 of 32. So difficult example, but a really good one.